So this is the lesson 3 video for the adapted booklet. Please make sure you are looking at the right video, otherwise your notes aren't really going to make sense. And so if you have the adapted booklet and you're looking at these notes, I would like you to take some time to add these keywords onto your word wall. And so I would like you to add a chord. And so a chord is any line that has both endpoints on the outside of the circle and it doesn't touch the center of the circle, right? Like if this was the center, we wouldn't call that a chord anymore, that would be a diameter. So chords are all those other lines that aren't diameters and aren't radii that go through your circle, and it doesn't touch the center of your circle. Okay, the second word you need to add is your central angle. So central angle goes through the center. The center of the circle. And so it starts on the outside and it goes to the center and then it goes to the outside again. And it can go that way or it could go this way. There's any way it could go as long as the middle of the angle is at the center of the circle. So please add a central angle onto your word wall. The next angle I want you to add is an inscribed angle. This angle is a little bit trickier, but basically what happens in an inscribed angle is you make a point on the outside of a circle, and then you go to another point on the outside of a circle, so we've got a chord, and then you go to another point on the outside of the circle, so then we've got another chord. Okay, so all 3 points of the angle are on the outside of the circle. None of the points are at the center of the circle. The last thing we have is an arc, and so an arc is just part of the circumference. And so I want you to think of arc as like pizza crust. Okay, if circumference was the full pizza crust, arc is just a part of the pizza crust. So we've got this piece of pizza, and then we've got another giant piece of pizza, and then we've got, looks like 2 pieces of meat missing there. So the arc portion is this curved bit and this curved bit. Those are the arcs. Okay, so we're going to start to use these properties. This might get a bit confusing. If it does, stick with the video as best as you can, and we can definitely talk about this more in class. So we want to talk about inscribed angles property and central angle property. So the first thing is if we have 2 inscribed angles that have the same arc, they are equal. So again, remembering that arc is like the pizza crust. So I want to try and draw 2 inscribed angles that both start at R and end at S. So I'm going to start at R. And an inscribed angle can't go to the center, so I'm going to find a line that I can follow that goes to the outside of the circle. And I'm going to go to A. And so I've got one chord drawn, and then I need to go from A to another point on the circle. And so I can go to S. So we have angle A, pardon me, we started at R. R, A, S. So now I'm going to try and start and end at the same spots, but following a different path. So I'm going to start at R, and I'm going to follow that other chord to B, and then I need to get to S, and this chord will take me to S. So we have angle R, B, S. And so what the inscribed angle property says that these 2 angles will actually be the same value. So if this angle, let's say, is 25 degrees, then this angle is also 25 degrees. And I hope by looking at them you can see that they look really similar. So that's the first property. The second property we need to deal with says that the measure of the central angle, so remember central angle goes through the circle, through the center of the circle. So central angle is twice or 2 times the measure of the inscribed angle that has the same arc. So the arc for this central angle is A to B. That's the pizza crust for that angle. So we need to use the same endpoints or the same angle, same pizza crust for an inscribed angle. And so if we start at A, we can go to D and then B. So we have the same angle, same arc, and then in central and inscribed. And so what that says is the central angle is 2 times as big as 40. So 40 times 2 is 80, or 80 divided by 2 is 40. So we're going to use these properties to kind of help us out. Okay, so we have arc AB. We have an inscribed angle, AEB, that's 35 degrees. So if you remember our inscribed angle property, it says if you have 2 inscribed angles that have the same arc, they have the same value. So I'm going to start at the same point. I'm going to start at A, and I'm going to follow a different path to get to B. And so this angle is also 35 degrees. So angle ADB is inscribed angle. ADB equals angle AEB because the angles share the same arc. And the arc is AB, right there. Okay, so if angle AEB is 35 degrees, that means angle ADB is also 35 degrees. Okay, the next thing we have to find, so I'm going to do a little bit of erasing here so we can see this a little bit better, is we're still going to use that arc, and we're still going to use this inscribed angle. Whoops, that's 35 degrees. But now I hope you notice that we have a central angle, ACB, that has the same arc. And so because we have ACB that is a central angle, it's going to be twice or 2 times the inscribed angle that has the same endpoints. So AEB we said is 35 degrees, and so the central angle is going to be 2 times that, so 70 degrees. So the central angle ACB is 70 degrees. Okay, that wasn't so bad, was it? I hope. Example 2. We're going to use central and inscribed angle to recognize relationships. Okay, so hopefully you notice that A to B is 10 centimeters, and this is the diameter of the circle. Okay, so the diameter is 10. We have a chord from B to D that is 6. And we want to know what is the measure of angle ADB. So we want to know what's this angle. ADB, we want to know what that is. And so ACB is a central angle. ACB is a central angle. And it might not look like a central angle because it's a straight line. And so a straight line or a straight angle is 180 degrees. So since AB is a straight line, the central angle is 180 degrees. Keeping in mind that the central angle is twice the inscribed angle, we're going to divide this in half to get the inscribed angle because they have the same arc. Right? Technically, they both start at A and end at B, so then this is the arc that they both have. These have the same endpoints. So we're going to take 180 degrees and divide it by 2. And so we get 90 degrees. So angle ADB is 90 degrees. And this is actually kind of a special property. An inscribed angle that uses the endpoints of the diameter is always a right angle. It's always at 90 degrees. So if we go back up to how we drew that circle, we can actually draw this angle as a square because we know that it's a 90-degree angle. It's a right angle. And this is a special property. So you might want to make a little star beside that one. Okay, the next thing they want to know is what is the length of A to D? So they want to know what is that length? And so because we have a right triangle and because we know 2 other side lengths, we can use the Pythagorean theorem. So on your notes, I've recopied the triangle down. And so this is the length that we want to know. And so, again, first thing we do, it's a 90-degree angle, so we know it's a right triangle. I'm going to shoot an arrow across to find the hypotenuse, and then the other two sides we could label as A or B. So, this is A, this is B, this is the hypotenuse. Okay? And we know the hypotenuse, so we're looking for one of the side lengths. I'm actually going to rewrite this out. I don't like how I wrote these notes. I changed my mind. And so we need to subtract. So we're going to go hypotenuse squared, take away A squared, because we know A equals B squared. And so the hypotenuse is 10. So 10 squared, take away 6 squared equals B squared. And so then we get 100, take away 36 equals B squared. So we're subtracting 36, same as what I've said in the other notes. Okay, and so then we get 64 equals B squared. Well, that's kind of like here, if you want to follow those in. And we don't want to know what the area is, we want to know the side length, and so we need to square root. And the square root of 64 is a perfect square, which is 8. And so square root of 64 gives us 8. And so the length of chord AD is 8 centimeters. Okay, third example, pardon me. I know this video is getting a little long. This one has a little bit of problem solving. So it says, Jamie photographed his house using a lens with a 70-degree field of view. So what that means, if he's sitting here, he can see 70 degrees in front of him. He wants to take another photo, but he only has a lens with a 35-degree field of view. Where could he stand to take a photo of the whole house? And so hopefully what I want you to notice is that he needs to step backwards. Okay, so we need to think of this as like so if this is the radius, okay, we need to think of a circle going around his house, so you can maybe use a compass. And he needs to be somewhere on the outside of the circle, because any of those will then make a 35-degree angle. So if we go down to just where it says solution, so in order for us to draw another place he could stand, we are going to draw a chord from the side of the house to a point on the circle, and then draw another chord from the opposite point of the house to that circle. So we're making an inscribed angle. Okay, so there's one point, but this is another possibility, or this is another possibility, or this is... There's any possibility that has the middle of the angle at the outside of the circle. So this is your assignment. You are going to work on this in class, and then we can check them together as you go.